we're going to be looking at the inverse of exponential and logarithmic functions. We're going to be basically following the steps for an inverse to show that the exponential is the inverse of a log and a log is the inverse of an exponential. All right, so let's start with the function f of x is equal to 10x plus 1. First step here is to make my f of x y. So this is y equals 10x plus 1. All right, then I do that mirroring across the y equals x. So any x is now y and any y is now an x. So this is going to be x equals 10y plus 1. All right, I know that from log properties that if I have a log base b of b to the x, this ultimately just becomes the exponent of x. So what I'm going to do is I'm going to do a common log. Since this is a common base of 10, I'm going to common log both sides. So this is going to be log base 10 of x. I'm not going to write the base 10 because, again, this is a common log. Log of 10y plus 1. All right, again, knowing the property, if you have the same base, your solution is just the exponent. So this guy right here ultimately becomes y plus 1. Okay, so now we're looking at log of x equals y plus 1. Subtract 1 from both sides to isolate y. We have log of x minus 1 equals y. Replace the y with my inverse function. So we get log of x minus 1. All right, graphically, this is just going to be a rough sketch. It's not going to be too accurate. Boop-a-doo. There we go. We are actually log base 10. Our graph has moved down 1. So remember, our graph would normally pass through 1, 0. We're going to move that down to -1 here. And then over here at 10, this would be 0 because this used to be 1. All right. My vertical asymptote is the same here. And again, that's the same. This is, we're going up by 1. So if this is 1, we're going to go over by 1 this way because it's the opposite. So this would be here. I'm going to try to draw this as good as I can. There we go. That's the best I got. It's not actually the best that it can be, but this is mirrored across the y equals x plane. All right, so there we have the inverse of an exponent. Let's look at the inverse of a log. We're going to have f of x equals log base 7. And again, this is now not a common log. This is a log base 7, x plus 5. First things first, change the f of x to y. Y equals log base 7, x plus 5. All right, now switch my x's and my y. So x equals log base 7, y plus 5. All right, I can raise this to the 7x. So this is 7x equals 7 log 7 y plus 5. So this is another one of those properties. So if I have a base raised to a log of base of x, this ultimately is just going to be x. All right, so this is going to be 7x equals y plus 5. And then now what we're going to do is just subtract 5. So 7x minus 5 equals y. Then make sure that the audience knows that we're working with an inverse function by doing f to the negative 1 of x equals 7x minus 5. And there you have the inverse function. This one, I'm just again going to draw a rough sketch. Not going to be precise. Get this a little bit further up. I wish I could just type in 90 in there. I haven't tried, so. Alright, so we're looking at 5 back, 1, 1, 2, 1, 2, 3, 4, 5. So this is now my vertical asymptote, which means this guy moves back 5 here, and this comes up and over like that. And my inverse function, again, we're going across this guy. So my inverse function will have, we're down 5 for my horizontal asymptote. And so we're going to look something, I tried to use red for that one. We're going to look something like this. And if I had actually drawn that right, this distance should be the same here to here. And it's not, but it should be. So that is the inverse functions. Yes, my inverses can cross and intersect my regular functions. Again, it's just a mirroring across that line. So you might actually have a point where you have like 1, 1, and those will actually intersect because the mirror of that is still 1, 1. Alright guys, so if you have any questions or comments, please feel free to contact me, and I will catch you in the next video.